Without collaborative and intelligent radio technologies, today's spectrum regulators and planners have to make worst-case assumptions. When it comes to protecting grandfathered spectrum users, regulators must enforce large keep-out zones to insulate these incumbents from harmful interference. The Incumbent Protection Scenario explores the question, can artificially intelligent radios collaboratively mitigate their interference to an incumbent radio system and thus unlock unused spectrum resources? In this scenario, teams are positioned in a neighborhood near a satellite ground station and transmitting in the same frequency band as the incumbent satellite receiver. The scenario moves through 3 stages, where the ground station is positioned closer and closer to the team's location, making it more and more difficult for teams to achieve their communication objectives without interfering with the station's operations. The station uses the collaboration channel to periodically broadcast its measured interference to the teams. The incumbent system will tolerate only a minimum level of interference. This line indicates its threshold at any given time. Once the aggregate interference from all the teams combined crosses this threshold, the incumbent will declare a violation and all scoring will be temporarily suspended until the teams reduce their interference. In addition, the incumbent system enforces a further penalty by lowering its threshold after every violation for a period of time before raising it back to the original threshold level. In Stage 1, the ground station is far enough away that all radios can transmit simultaneously with a slight reduction of power. In Stage 2, the proximity of the ground station changes the game. Now teams must collaborate to limit the number of radios communicating simultaneously to avoid breaking the incumbent's threshold. The ensemble must ensure that only 10 radio nodes on average are active at once to avoid incurring a penalty. By Stage 3, the ground station is so close that only a single radio can safely transmit at any given time, requiring the entire ensemble to collaborate at precise levels of performance in order to provide every radio enough time to achieve its objectives. The communication demands being put on the radios at this